I want to return to the delta V map for just a minute and mention that there are a number of asteroids out there, and that these are just a hop, skip, and a jump from Mars. And so I thought, well, you know, if there were things that were valuable in the asteroids that you could actually sell, they would be easy to access from low Mars orbit rather than from the surface. And so, you know, you have to ask, well, what are asteroids anyways? And some of them are made out of methane, which is fuel. Some of them are made out of rock. If you have energy plus rock, you can make structural materials, you can make batteries, you can generate chemical enthalpy sources. But there's all these gas stations out in outer space waiting for us to access them. And so I thought that once you start to think about space as a medium that needs to be explored, then the economics of how to do that suggest that you make the maximum use of the resources that are already out there. So, in summary, as a simple-minded notion, if you just look at the energetics of obtaining hydrogen and oxygen, the energetics favor doing so from the moon. Now, of course, you can bring up the infrastructure, and I'll readily admit that, yeah, we have a lot more assets on the ground here on terra firma than we do on the moon. But from an energy standpoint, there is a big advantage, a factor of 10 advantage, in obtaining the fuel from the moon. I also think that if the numbers work out right at some level of production, that you could reach a point where there's cash flow positive operation, meaning that the revenue that you generate from sales or credits for propellant generation are enough to sustain additional operations. Also, it occurs to me that many asteroids themselves are made out of rocket fuel. Some have water ice, others are even better materials such as methane, and others are made out of construction material and ores. Those could be accessed. They could be brought to Mars, to Moon, to low Earth orbit, wherever you want. I kind of think that some of it might be well to bring it to orbit around Mars as a convenient place to keep a station. That's the place where you can do the maximum amount of consumption of these propellants. My thinking is that that's beginning to describe how to make a space-based economy. So I'm thinking that our oil persons from, say, Texas and maybe Alberta, Canada, might someday be looking at Mars orbit as a means to extend their operations. And also I'll conclude that this presentation is not part of my normal work at West Virginia University, which involves coal conversion and coal liquefaction, and I'm pleased to say that absolutely none of it was paid for by BP. And I think I have a few minutes for questions. Yeah, I guess we'll use the microphone, please. Yeah.
Okay. You said that it was about a 3% payload bringing fuel up from low Earth orbit?
Yeah, I'm saying if you have a generic launch vehicle, that I think the payloads are just a few percent.
Well, a long time ago I computed that, and 1 pound or 1 kilogram in LEO costs you 7.8 kilograms at rest for launch if you're launching with ISP of 455 seconds, which is liquid hydrogen. So that's about 11-ish% minus a bit for tankage around your cargo.
Okay.
The other thing is, did you look at how much mass was required to extract the gases from the lunar regolith before you apply the enthalpy to cook them out?
No.
Okay. In point of fact, when I checked on this long ago with Kolsinski, he sort of quoted me a design point for a lunar miner, which consisted of some 62 metric tons of mining equipment, which had to be pushed up to the moon before you could scrape all the regolith up. And the enthalpy is easy because you can have a solar collector, but pushing 62 metric tons to the moon is a fair amount of investment. So the trade looked like if you could get that tonnage to the moon and pay your mass trade within a fraction of a year, then it looked very attractive because you'd have this mass up there on the moon and it would be working semi-automatically, and if it ever broke, you have to replace it. So you want it to pay its own shipping freight within a few months. And then you'd have to get close to some ilmenite to pull your oxygen off. But if you didn't do that and you had to get oxygen from the regolith, it would take much longer, perhaps even 2 years to pay your mass trade. So isn't that a factor that you have to look at?
Yeah, no, I think I agree with the arguments that you're making. My second bullet there points out that you might be able to have cash flow positive operation, but I think the initial capital cost requires some stimulus money. I don't think we would pay the capital costs anytime soon. I think that your whatever you put up there would have to have a operating lifetime of some 10 years or hopefully 30 years, which is kind of what we expect from operations on the ground. It has to be a long time in order to realize, if it's going to start to look like a balance sheet that would pass muster on Earth, you're going to have to talk about operations like that.
My question is about the quantity of water found. I've heard various very conflicting accounts from right after that penetrator probe that they first found the water. Zubrin wrote a piece, and if I remember correctly, he stated something in there that yes, there was water found, but it would be less than found in the driest deserts of Earth. And then other people seem to be talking about, like equivalent of frozen lakes or frozen oceans, and these are such at extreme opposite ends of the spectrum. Where is the truth lie?
Well, I think I mentioned during the talk that when these estimates first came out, a lot of us were pretty skeptical about them, and in fact, some of the measurements that were made were based only on detectors that were sensitive to hydrogen rather than H2O. And so some of us thought that, well, maybe this is just protons from proton flares that have embedded themselves into the lunar soil, and they're generating a signal, but they're not really water. And then later estimates have gotten larger, and this most recent estimate is within the past year, based on a synthetic aperture radar from NASA, and their published estimates are in the range of millions of tons.
What percentage?
Pardon?
What is important is the grade of the mineral, not the total quantity. What is the grade? The concentration.
The grade?
Concentration.
They're talking about inside a crater that the water can exist as ice, and that the vapor pressure is low enough that it doesn't evaporate. So some of it could be pretty pure, and others might be a blend of like sand and ice, and maybe that's like a 50-50. But the point is that it's very accessible, so that if you heat it up and melt it, you could filter it or centrifuge it, whatever you want to do to it to purify. But obtaining water from sand water mixtures, I don't really think is a critical issue. I think it's pretty well at hand, and I don't actually need millions of tons to run this operation.
The Upcross impact cited the several percent water and other volatils.
The whole issue of propellant extraction from local resources is very important, and we're starting to realize, of course, on Mars there's a lot of ice subsurface in some areas fairly close, for distance away from the poles, but also even earlier, we may be able to extract propellants from Phobos. There's another Russian mission that will attempt to bring back samples of Phobos. We don't know. We surely can get oxygen from Phobos. We don't know if there's any water content in Phobos rocks until we get them back. But if that was possible to extract water from Phobos, which is similar to an asteroid, you would be able to then get both oxygen and hydrogen in Mars orbit to take cargoes down to the surface of Mars, which is directly applicable to the goals of the Mars Society, obviously, is to get stuff down to the surface of Mars. So the closer your source of propellant extraction is to where you're going to use it, the better. So we need to look at all these different options and continue to develop the ability to extract propellants and to store them for long periods of time.
Thank you. Okay. Thank you.